We're going to go through our experience, kind of how we got to be on GCP and what our experience has been when we got there and a lot of things that we learned. We're also going to talk about, I guess, some of the things we might have done differently if we had our time again. So there'll be plenty here for everyone, I think. Really happy to be here with a couple of my teammates. I'm Marco Della Torre, I'm the CTO of Derive Systems. Over in the blue shirt is Scott Nelson, who's our Director of Software, and DJing this event is Jim Martens, who's our Data Science Team Lead. So we're going to have some really fun demos from these guys, talk about architecture, and also just get a sense of how we fit in the world. So I thought I'd start out just letting you know what we're going to be up to. So a bit of a primer on our industry. We're in automotive IoT, so we put little devices inside vehicles that do really cool things. They're LTE connected, they collect all sorts of data from vehicles, and they also rewrite the software of vehicles. So one of the things that sets us apart is that we do vehicle write access to make vehicles more capable than when they get to you from the factory. So we'll talk a bit more about that. Give you a sense of kind of what the market opportunity was that we went after. Obviously do some fun demos, because that's what everyone's here to see, and then talk a little bit about the tips and lessons learned that we had from doing all this. So we'll start out a little bit. I'll talk a little bit about our industry, just give you a lay of the land. For those of you who are about to or have already started building an IoT platform, a lot of this is going to apply directly. This will just give you kind of the surface layer of how our customers are special to us, but obviously all the firmware, cellular connectivity, mobile apps, the data flows, that's probably going to be really familiar, and we hope it is, because we want you to learn as much from our experience as you can. So this is a little bit about the history that precedes us at Derive. So really dates back a number of decades as things started to become connected and smart and digital. So starting out with going to the PC, and more recently our connectivity becoming linked to smartphones, even our homes going smart, our doorbells are smart now. This is one of my favorites. Our ovens are smart now, it's pretty cool. Shout out to anyone from June Oven who's in the room. I think the only one that tops that is this, our toothbrushes going smart. This is really something that the social media networks are trying to sell me right now. I haven't seen toothpaste go smart yet, but I think that's probably next. So the question is, why is the biggest appliance in our lives, maybe one of our biggest assets in our lives, also one of the least smart, connected, or integrated? And that's these little guys on the right-hand side. Why are these things static after we buy them? We get to choose the paint, maybe a couple of options, we drive them off the lot, they never change again. In fact, they drive off the lot not even knowing how we're going to use them. Are we going to be using them for law enforcement, or for delivering packages, or picking up groceries, or dropping the kids off at school? The OEMs don't know, so they build them all the same. A little bit about the industry we play in. It moves very slowly. There are about 270 million vehicles in operation in the US today. So a lot of vehicles on our roads. Each of those vehicles has a lifespan of about 11 years. So if you do that math, yeah, it takes a real long time for the industry to change. The vehicles that roll off the lot today are going to be out there for a dozen years. It's going to take 15, 20 years for the industry to change the entire set of vehicles that are on our roads. Just to highlight that some more, the first modern vehicle appeared around 1901. You can debate what modern vehicle is, but that's about right. Well, we had about 95 years of that. 96, the first electric vehicle happened. Here in Silicon Valley, we think a lot about Tesla. We hear a lot about Elon and his folks. Man, it's been more than 20 years since electric vehicles started. And now they're a little over 1% of the industry. So this industry moves really slow. While it's moving slowly, we love the idea of everything going autonomous and electric and maybe flying or who knows what. The reality is these vehicles are out there with incredible networks of processors running software that we can upgrade. So what we've gone about to do at Derive and what we offer to consumers and to fleets is the ability to modify the software inside vehicles to make them mission specific. So that means whoever you use that vehicle will give you the software that does that mission best. Okay. It's something we've been doing for consumers for a long time. It's something that we've just recently, in the last few years, started doing for enterprise fleets, and we're the only people that do it. And we do that through an IoT device that goes in the vehicle, and that's a real big differentiator for us because we're the only ones that write the software. So we're going to talk about the platform that kind of powers that differentiator for us. Just to give you a sense of why this works. So have any of you out there ever used kind of a Fitbit or a health device? I built one of those one time. Yeah. Humans, really difficult to change the software of you guys. So we think about this in terms of enterprise fleets. What's happening out there are devices are collecting information about vehicles. So for example, how fast the vehicle's going or who's driving it. Fleet managers are coaching drivers, like, hey, I see you're speeding out there. Be great if you didn't do that tomorrow. It's just like the Fitbit, like, hey, 9,000 steps today. How about 10,000? Like, really hard to change the habits of humans, right? So we're out there trying to coach these drivers. Drivers are doing the right thing about 50 to 80% of the time. And by the way, each year about 20 to 30% of the drivers in a fleet leave. So you get to start again with that 20 to 30%. So it's really tough to win this battle in the automotive industry. I think the biggest thing that drives failure here is that these behaviors are at odds with operational KPIs. So if you think about drivers in a fleet that have to make a number of stops each day. So you got to make 8 stops today. So I don't want to pick on you. You're just closest to me. You got to make 8 stops today to get your paycheck, okay? But you're not allowed to speed. Well, if you get to stop 7 and it's almost the end of the day, guess what you're doing to get to stop 8? You're breaking that speed limit all day. So one of the challenges is that operational KPIs are directly at odds with how people drive the vehicle. So because we have ride access to the vehicle, we're thinking about this a different way. We modify the way the vehicle operates, so it doesn't matter how you drive it. So for example, I can stop that vehicle from speeding. You can put your pedal to the metal. It's not going to speed. So here's a case study that kind of talks about these 3 things: saving lives, lowering environmental impact, and technology that pays for itself for these big appliances. This is a big major national fleet that we work with. So let me just walk you through this real quick. There are 2 lines here, orange and blue. Apologies to those of you who are colorblind, but I'll walk you through it. It'll be obvious anyway. The blue line represents our control group. So these are vehicles that we didn't upgrade the software on at all. And as you can see over time, being the bottom axis, man, these people keep speeding. The speeding violations just continue. And these folks were coaching their drivers, telling them not to speed, pleading with them not to speed, and humans just keep speeding. The orange line is our test group. So this is the set of vehicles that we modified. And you can see at the start, man, they weren't doing so well. They started out in a similar place, they sped a lot. We upgraded the software of those vehicles so they wouldn't speed at a level the fleet deemed unacceptable. As you can imagine, if the vehicle can never exceed that speed, violations go to 0. So that's the difference between trying to change the software of humans and changing the software of vehicles. Bit of a video about us. All right, that gives you the lay of the land. So for those of you who are building IoT platforms or thinking about building IoT platforms, that's kind of the world in which we live. Building IoT devices that go inside vehicles, that have a really unique differentiator, they're connected. And this is our product market opportunity. So think about your product market opportunity. It's going to fit a lot of the same things. In our case, we deal with these vehicles that are running generic software. We live in a commoditized telematics industry, so this is just folks who are out there measuring GPS location and not able to write to software of vehicles. That's about an $18 billion industry. We brought mission-specific vehicle software upgrades. That's our big differentiator, but of course we also offer telematics and all the commodity features as well. And we built a platform that goes after this and brings it to market. And we're going to kind of walk back through how we got to that. But ultimately, combining those four things meant three key features for our customers. One being fewer collisions, just drivers out there having fewer accidents. And if they're having accidents, they're much less severe. Secondly, having a smaller carbon footprint, so we reduce the amount of gas that vehicles use, which has a huge sustainability benefit. And lastly, lower costs. So by reducing the amount of gas that fleets are consuming in their days, they're spending a lot less. Actually pays for the technology itself. So nice little market dynamic there, where by making the fleet less expensive to run, they can afford to buy our technology and then some. When we looked about this product market opportunity and selecting a cloud vendor, there are kind of three main criteria we looked at. First was speed to launch. We saw this huge market opportunity in this $18 billion market with this unique engineering capability. And we wanted a partner that could support us to get right into the market as quickly as possible. We wanted to go capture this thing while we're the only ones that could do it. Second thing, we were getting huge market demand signals because no one else was offering this to enterprise fleets. So we wanted a partner that could scale with us. So not just launching quickly, but then being able to meet the demand that came with that. And lastly, we're putting connected devices inside huge machines. This has got to be secure from board to cloud and back again. So these were the three main vectors for us. And obviously, we chose Google. So I'm going to kick it over to Jim. Jim's going to talk about how we went from really nothing to standing up our first fleets. Our fleets typically stand, about 20 million data points a day. And Jim had to stand that up from scratch, making it happen. So Jim, over to you.
Thank you, Marco. Hopefully I'm coming across. I had to move the mic. I learned about a term called beard noise. Maybe you might be still getting a little bit of that. It's really impressive that all the tools that Google and GCP provides, especially to those that are trying to get started with IoT. The communication to IoT, as some of you may know, I know some arms that went up in the air earlier, but is MQTT. There are open source libraries through PAHO and documentation on getting devices registered and set up in the cloud really quickly. It was important to us to get a proof of concept and have data coming from whether even they be virtual devices and getting those pushed in the cloud and have that pathway established to understand how we would take that same technology or that same methodology and bring that over to the firmware. So for this particular, I won't go too deeply into it, but I'll take one of these open source Python files and slightly modify it and then send some data up currently just to show kind of end to end. We'll first off take, one thing that's nice about this data script is, or this particular Python script, is that it establishes the MQTT connection and sends that data up into the cloud that we can then verify. Like I said, we'll change a few things when it comes to the data payload. This data payload is very particular to us. It's something, the types of things that we care about, especially when tracking a vehicle. So we're talking about latitude, longitude, speed, those types of things. We're not going to get too creative, but we will update the time. And maybe we'll change the latitude as well. Or we can change the course in this particular time. All right. So again, this script is simply going in and pushing up the payload that we've selected for a given virtual device. And then we would like to verify that that data has gone up. Here we have our demo next device, 19. Now, our process for this is sending data into BigQuery. It's from BigQuery that we pull all data for analysis and any other processes that we're going to do analytics further on down the road. As we can see, we've recently sent the most recent message. The data we know is coming through. This is not just helpful for proving that we have a simple data pipe going from end to end, but this proves particularly useful when you're doing development further on down the line. When you're trying to do testing, trying to do any sort of scaling testing, anything along those lines, trying to do it here before you're actually trying to push these changes into something much more complex, such as firmware or these IoT devices that are inside vehicles. Of course, the GCP console gives you access to many, many things, from being able to track devices that are inside your system or being able to track monitoring of said devices. Of course, we went from a development environment to looking at what is actually production for a fleet that is in existence that is sending out up to 20 million messages in a given day. You're able to traffic or monitor the traffic for MQTT traffic, device operations, errors, which are luckily quite low, byte traffic, and what is the billable data that is being sent across. And in our particular model, we're sending all of our data to IoT Core, and then that data is being processed by serverless functions or cloud functions, as the case may be. Again, we tend to see a similar kind of pattern in this case, where we get to see the traffic or cloud functions that are being instantiated over the course of a week. For ourselves, we see that there seems to be a particular kind of pattern, and this is particular to our IoT use case, in which case we have drivers that are in a fleet, and their typical traffic is peak for midday across the United States. And then in the evenings, we see quite a decrease in traffic. For ourselves personally, even though these devices aren't sending on a quick, regular basis as if they were actually in traffic or actually moving, our devices still send data even when they're not active necessarily, just to let us know that where they are and how they're doing. And then if we look at something on the weekend, we see less traffic, which is pretty expectable, one hopes. Again, there's a wide range of information that you can pull from different cloud platform graphs and charts, understanding how many different instances are being served up to handle the kind of traffic that's coming through. One thing that's really important to us is looking for spikes. Spikes are what tell us that possibly something's going wrong, or there's something that when we're sending data, whether it be to BigQuery or a third-party endpoint for collection and other processing, it's those spikes that let us know that there's a problem and kind of alerts us to some sort of action. Another important tool, especially if your data is being passed through cloud functions, is to watch for any errors that might be going across that require further investigation. A lot of the times, when you're sending 20 million packages in a day, you're going to get errors, whether that be possibly internal connection errors to where you're trying to save the data, or external errors to where you're trying to send the data to. One thing that's really powerful about IoT is that, or PubSub, which is what IoT feeds into, is that if a message doesn't reach its endpoint, if there is an error, it isn't lost. It's sent back to the beginning. And generally speaking, this is what you see with spikes, is that a data didn't reach its endpoint, and it's gone back to the front of the queue, and we'll try to go again at a later time. Metrics and ability to observe what's going on within the system goes much deeper, and typically this is within Stackdriver. Stackdriver allows you to set very specific parameters on what you may be wanting to watch, whether that be BigQuery reads, BigQuery writes, or anything within the entire GCP platform that you need to monitor. What's more powerful than that, and has proven useful time and time again, is being able to set alerts within Stackdriver. Such a case might be that SQL usage is reaching a point that it might cause problems. And people who've developed on GCP know that there are set limitations, resource limitations and API limitations. And you can set alerts and policies within Stackdriver that allow you to know a problem before it occurs, before it stops and causes problems within the system. And with that, pass it back to Marco.
Awesome. Shameless round of applause for Jim for a live demo. Brave. Cool. So that gives us a sense of just how we went from zero to getting the back end going. And we'll come back to the architecture a little bit. Scott will walk us through that. But once we got the back end working, got the data flowing in our system to support this volume for our fleets, we started to build the user experiences. So obviously, building the data flows is great, but our customers have to have something to work with. So here's some examples of things that we've built and we're building for our customers. So obviously starting out with web and mobile data, so ways for drivers to interact with the system as well as fleet managers through dashboards and visualizations. We offer distracted driver prevention, so when the vehicle comes out of park, we lock the phone down so drivers can't be sending SMS or making calls. It's one of the leading causes of collisions, and we just take that right off the table by making sure that if they're in drive or they're in reverse, they're not texting. Seatbelt enforcement we're really excited about. This is one where it prevents the vehicle from even starting until the seatbelt is on. We know that most collisions in a fleet happen within a really small radius at the start of a drive. That's also the time when you're least likely to have put your seatbelt on yet. And for a driver in a fleet that's making 8 stops a day or 12 stops a day, it gets kind of a hassle to take that seatbelt, put it on and off every time, so they tend to skip that. Well, that's why they get in accidents and hurt themselves and others. So we're taking that off the table by making sure that that seatbelt's on every time. And lastly, dynamic speed governing. So we can offer fixed speed limits for vehicles, so that vehicle just never goes above a certain number. We're starting to do dynamic speed governing as well. So looking at the location and heading of the vehicle and applying the speed for that road, or a speed relative to that road, to the vehicle. Nobody needs a delivery vehicle doing 100 miles per hour down their street to get to the next stop. So we stood up the back end, we started to build the user experiences, and it took off. We work with many of the nation's largest fleets now, including one of the top 5, and that one fleet generates about 20 million data points per day and has more than 25,000 vehicles. So even as we just started to build this thing, the demand was there, and it's only taken off since. So going up to that higher level of experiences, I'll turn it back to Jim and show us kind of how we turned that back end of IoT Core and PubSub data flows into user experiences for our customers.
So of course, just establishing that data is kind of getting from point A to point B isn't entirely that useful. BigQuery proved to be one of our best tools for identifying devices in the field that might be causing problems or just not behaving as we expect them to. Identifying individual errors with logging, while at times was useful, it didn't give us the kind of insight to help us dig on particular issues. Being able to find specific vehicles and how they're behaving was a simple thing to do within BigQuery. There are other types of queries that prove to be quite useful, like trying to identify devices that haven't reported GPS in some amount of time. All these devices that we have, they have LTE, they have Bluetooth, and they have GPS connections. So while as your phone may also have GPS, the device is supposed to be reporting its GPS at the same time. There's a number of reasons that that might not be happening. You may be in a cityscape or a valley that doesn't have GPS, or at the end of the day, the driver takes the vehicle and parks it in a garage, or it gets taken in for services. And so for all intents and purposes, this device kind of disappears to the fleet possibly. So being able to find these vehicles that aren't reporting as we expect them to is something that's particularly important. We can then go in and try and track down what's happened to those devices. Now, all of these tools, very useful for ourselves internally while we're in this development process, while we're trying to go through these steps of setting up this fleet of 25,000 vehicles or any fleet that we're working on. But it doesn't really add much value to the user. As Marco said, that's what we're really trying to drive towards, is get something that's useful for them for tracking data, for being able to track their fleet, manage their fleet, gives them real value. We were able to do this relatively quickly with, again, using just a Google product, being able to pump data from BigQuery into Data Studio, which allowed us to, without using BigQuery, and it's something that's a better tool, even internally in some cases, be able to track down specific vehicles, when they last reported, when they last pulled information that they were expected to pull. But then we wanted more than that. And so for that, we needed to kind of elaborate on our architecture a bit. Back to the slides.
Thanks, Jim. This is Derive's Google Cloud architecture. It's simple, but when we started, it didn't feel simple. For us, we had excitement, we had confidence, but we didn't have experience for building architectures that will handle 25 million messages a day. We took a very iterative approach to this, as Marco and Jim has mentioned, and I highly recommend building this in layers and building layers upon it. It's a strategy we did during development, trying to get to market quickly, and it's a strategy we leverage for our roadmaps and for further capabilities that we add. And I would like to walk through the flow and sort of highlight some of the big milestones, starting with our device in the vehicle. So as Jim initially demoed, a big milestone is working on your ingestion and storage and getting this set up in a proof of concept to really start seeing your data that you wish to flow through the cloud and get the tool set you need to really visualize it. This was empowering for us from a development perspective. This let us check off a lot of the architectural considerations that we had. IoT Core really proved out the scalability and security. PubSub with the reliability, being able to handle data spikes that we see from time to time. And cloud functions with the stateless execution of horizontal scalability. On BigQuery, BigQuery is a tool that we leverage a lot. The SQL nature, the ability to see data in very cost-effective queries is a platform that we really developed to really see what we were trying to build. And it enabled quite a few things. It enabled us to really dive deep and try to visualize what we wanted to create in applications and identify data integrity issues. Is our devices, do they have issues with the metrics that they're streaming? And it helped identify missing metrics for the capabilities that we're trying to capture. And this is a milestone that allowed us to iterate and do full stack changes in a pretty efficient manner. So as we start seeing more metrics and ingesting them, we can work with that without really impacting the rest of the stack. The next piece that's pretty critical that for us has been a challenge and is ones that we're excited to continue to work on is data processing. So for our messages from vehicles, these are very specific events in time. And we need to process that and start having some higher abstractions. For us, that's trips. That's seeing a individual, a driver, for a window of time, go to different locations. It's trips, and it's the insights that we want to show about trips. Specifically, that I'll get to when I show off a little bit of mission control. With data processing, we actually went through a couple iterations of it. It was definitely a learning for us on how to do this cost effectively. And there's quite a few tool sets that we haven't leveraged yet, but we have in our future. When it comes to the actual applications itself, this is a little bit more in our wheelhouse. This is what we've been developing for years. So it's really the data architecture pipeline that, at least for us with our experience, has been a great learning experience. So for mission control, this is our dashboard. This is our web application. And what you're seeing here is our first insights that we built. The graph in the upper left is showing insights on engine idle time. This is a fleet, and the graph shows the total amount of time vehicles were idling each day. It's a very simple, powerful visualization. And for this specific use case, we have a positive outcome of the idle time decreasing. This is caused by a couple of effects. One is leveraging our ability to upgrade the software on vehicles to help reduce the idle time. And then the second is just more visibility and accountability with individual drivers. If they understand their patterns, they do have an opportunity to try to optimize that. And similar to our layered approach of our whole data architecture pipeline, it comes up all the way to the end user applications as well. When we built this, we didn't have other visualizations. We didn't have data processing that went deeper than this. And as we added more capabilities to mission control, we continued to add what we need. This is the sort of opposite approach. Instead of insights, this is going into high fidelity, and this is looking specifically at a single chip. So this is more of a real-time and detailed representation of our data processing system. In this one, we're still highlighting a little bit of the value out of the system with showcasing not just the GPS locations, but the amount of idle time during that trip. And from that, I'll pass it back to Jim to really highlight some of the lessons learned.
And not on the demo, but actually just on the slide still. Oh yeah, you've got it. So I think one of the biggest lessons learned for us really had to do a lot with how best to most cost efficiently leverage BigQuery. BigQuery is an incredible tool to cheaply store data. It's a great data warehouse, and it's simple enough to pull data from it. But we had multiple systems, both from trip processing to just simple mapping that we were trying to do that at times could be pulling thousands of queries in a minute. We had to change that. We had to optimize a lot of the ways that we both store data and change data. And if anybody's worked with BigQuery, when you start getting into the terabytes of data on BigQuery, some of the most important things to keep in mind is make sure you use partition tables so that when you're pulling data in, you're only pulling the data you want. Ultimately, when it comes to cost, that's the biggest thing with BigQuery. Typically, you don't need access to all of the data that you're possibly storing. For us, that can be particularly true when we can have hundreds upon hundreds of columns of data that we're storing for any given event that comes across. So partitioning, particularly important, and making sure that you leverage your queries against those partitions. Sometimes we still see that happen within our own, where we're like, why did that one cost that much? Why did that one singular query cost that much? So trying to limit that. Another really great thing to do is denormalization of data. A lot of us come from a background of relational databases, and in that kind of an environment, you're thinking, oh, joins are no big deal, we'll do that. But again, when you're running lots of queries against huge data sets, you don't want that. And you want denormalized data, just have it in one table, so you're not doing joins on many, many, many queries. On top of that, again, trying to make sure that you're only pulling the data that you absolutely need. Stack driver is your friend. It's a great way to keep you from running off the rails. It's all too easy. It's all too easy in GCP to kind of shoot yourself in the foot. They give you all the power you're willing to pay for. And so using stack driver, which they give you, you can set things up that keep you kind of on the rails and alert you when you've possibly done something wrong. Things that we've tried to avoid, very similar to that. Leverage stack driver to try and avoid hitting or going over quotas before you find out because your services have started to stop, just shut down because you've hit your quotas. And another thing is, especially in an environment, it's important that you have a good DevOps group or that you have some sort of a DevOps operation because, again, it's really easy to set things up in your environment on GCP and you can forget that they're running and they're not necessary. So, yeah. And again, a lot of the same. Really leverage the tools within the infrastructure to help you keep things in track with what you expect. There's a lot of different services and they're always changing and they're always adding new features to help you. And Google is really quick and responsive when you come into issues that you need to deal with. One thing that's been very helpful to us, it goes beyond, there's the initial billing that you have, but you can take all your billing information and you can load that into BigQuery, and you can load that into Data Studio and really do deep drilling to understand what the costs and usages within your entire organization's systems are. And as a summary, pass it back to Marco.
Awesome, Jim. Thank you very much. Yeah, we've actually just started piping the data from billing back into BigQuery, and it's been a huge asset to us. So maybe that's for a future demo, but would really encourage everyone out there doing these kinds of initial builds to make that one of your upfront priorities. It's helped a lot. Just to run back for a moment, I know a lot of you are sort of thinking about or initially building. Would encourage you to look at this architecture and kind of consider it as a reference or a resource. And if it's something that you're looking at in terms of building a connected device and standing up an initial architecture, we'd love to help. So come talk to us about our experience. I think, as Jim said, we had some lessons learned, but all in all, it was a pretty smooth experience. And especially when it comes to support, I think that's one of the things for me that I would have changed about our experience is to lean on the Google folks earlier and more often. I think we were probably a little bit overconfident in terms of building things. And once we leaned on them a bit more, that was a huge support. So please take note of this architecture. It's working great for us, and we're extending it from here. And if we can help you with yours, don't hesitate to reach out. So just wanted to kind of end on a summary of kind of our experience, I guess. We needed a cloud partner. We had a pretty amazing opportunity and a unique differentiator when it comes to our feature set. So we went out and kind of shopped around. We chose Google for those 3 vectors, kind of speed to launch. And it was been less than a year that we were from kind of a vision on paper to a platform supporting some of the largest fleets in the country. Support for scale, which is now something that we're thankful for as we do that. And then obviously security, which we didn't have as much time to touch on, but something we'd love to talk about as well. We have launched successfully and with some great user experiences for drivers and with dashboards and visualizations, which we're really excited about. And we're growing the business from there with Google. We learned a ton, most notably that the reasons we selected this platform and this architecture actually bore out to be true. So it's easy to hear this stuff up front. It's really relieving when they actually turn out to be real. And with huge support from the Google Cloud team. They've really been pretty amazing about this. Next up, we're really excited about kind of exploring more of the ML side of the platform. We're collecting a huge amount of data now, and we're kind of doing with it what we know best, which is working with fleets directly, showing them their reality, and then upgrading their vehicles to get those benefits so they don't have to rely on driver coaching. But we're excited about what we're going to learn from this data that we don't already know. So really excited about that, and really appreciate you kind of letting us walk you through from our first kind of idea through the initial building of the back end, through to the user experiences and where we are today. And happy to answer any questions or to just dig in and help you guys build yours too. So thanks for the time.